Okay, so today we're going to cover section 5. Section 5 is on angles. So the first thing we're going to do is determine what makes up an angle. So an angle is formed by two rays that have the same endpoint. The rays are called the sides of the angle. The common endpoint where the two rays meet is called the vertex of the angle. In this figure that's drawn here, this angle at the bottom, there's three ways that I could name this angle that's pictured there. I could name it by its vertex, or I could use 3 points, or if the angle is labeled with a number, I could also call it that number that's inside that angle. So for example, for that, what I could do is put a little 1 inside here. And this has nothing to do with the angle measure. I'm just stating that this is angle number 1, so I could also name it angle number 1. So when you name it with the 3 points or the 3 letters that form, the 3 points that form that angle, you have to go in order. So you could either decide, I'm going to go in this direction from M to N to O, which is the first name, or you could go in the other direction, start at O, then go to the N, and then to the M. In this particular picture, the middle letter must be the vertex. And my vertex here is N, and that's where the endpoints of the two rays meet. So the middle letter must be the letter N. Now, when you have just a single angle, then you can get away with just naming it with just the vertex angle or the vertex point. However, on the next slide, when a vertex shares a point, when the vertex is shared, we can't just call it with one letter. We must use 3. So in this case, I can use the 3 points on each ray. So I could take M, N, O, and that could be the first name. Or I could reverse it, O, N, M, or because it's just a single vertex here, I could call it angle N, or if I add a number to it, angle 1. Now this little slanty looking thing in front of it looks almost like an L that's slanted or an inequality symbol. This is the symbol for the word angle. So if you don't want to have to write out the word angle, you can just put this picture in front of your 3 letters. Now, if you don't want to put that little symbol, another way to do this, you would call this either angle 1, angle N. So you would write out the word instead of putting this symbol. If you just list 3 points, I don't know if you're referring to the 3 points individually or if you're talking about them as an angle. Pretty good? All right. Now, this is when we have a vertex that is shared. So before, that vertex was only for one individual angle. Now in this picture, I actually have 3 different angles happening here. And vertex B is shared by all 3. So here, okay, so there's actually 3 different angles here. So I actually have the large one, which is right here, which consists of A to B to C. That's the first angle that you can see here. You can also reverse the order of the letters, or you could call it angle CBA. Then I've got a smaller one consisting of A to B to D. Or I could reverse the letters, D to B to A. And then the other one that shares vertex B is this one over here, D to B to C. Or reverse it, C, B, D. Notice on all of these, we can reverse the letters, and all of them have in common angle B as the center. The 3 angles that are pictured here, if I were to also have added in little numbers in here, I could have also said that this is angle 1, the red one, or this could be angle 2. Now I wouldn't add 1 plus 2 and say that the black one, the whole thing is 3. But if it had another number on it, let's say I put a little mark here and said that that angle together, ABC, let's say that was 5, then I could say that one is also 5, something to that effect. But again, notice on all of these, the middle letter is a B on all of them, because that is the location of the vertex. Again, I could not just say angle B because I wouldn't know which one you're referring to. Next, we're going to identify what it means to have the interior of the angle or the exterior. So the region that contains all of the points between the sides of an angle is called the interior of the angle. And then the region that contains all the points outside of the angle is called the exterior. So again, the red would be the interior. It's like inside the angle. And then everything in the blue, like if you're exiting, it's the exterior, what's outside of the angle. Next slide has the protractor postulate, and this is similar to the ruler postulate. So what we can do is this is going to be the tool that we use to measure angles. So here, if you consider OB and a point A on one side of OB, the rays of the form ray OA can be matched 1 to 1 with the real numbers from 0 to 180. So this is where you would start over here at 0 when it points to the right. And then if the other ray that is forming this angle, this OA, over here, we would use the inside numbers to find the measure of this angle. Because again, you're not going to start when you're adding up or counting to measure the angle. You don't want to start at 180. You would go from the 0 to the 10 to the 20 all the way around and using the inside numbers, and you can see that the measure of angle AOB is going to be 140 degrees. All this is saying that you can use your protractor to measure, and each one can be measures 1 to 1 with the degrees from 0 to 180. Now, if you were drawing an angle, and let's say the first ray that you're going to line up is going to be pointing to the left, notice again we would count up, and let's say we wanted to get the back side of this. So I would count and use the outside numbers when my ray or my side of my angle is pointing to the left, and go 0, 10, 20, all the way up to 40. So this would be a 40-degree angle. So when you actually use a protractor, right here where we're placing this vertex is like usually a hole in the protractor. And you would line up the vertex with that hole that's in the plastic protractor, and then you can measure it. Some of them even have a little plastic like arm on it or thing that you can line up to see where to point the angle to. But again, we're not gonna need to pull out a protractor and use it, but be able to read it and measure an angle if it's put on top of a picture of a protractor. And we're gonna see that coming up. Next is gonna be the classification of angles. So when you measure an angle, the tool that you use is a protractor. For our purposes right now, at least for the first semester, every angle measure we see in any of these figures are going to be measured in degrees. You're going to also see later on that an angle could also be measured in radians, but we're just using this in degrees. Now, we can also classify angles based on their measurements. So when we have an angle that measures between 0 and 90, so anything from 1 degree up to 89, or it could be 89.5. So really that's why they put between 0 and 90. This is called an acute angle. And one way that I help to remember that is if I break the word acute apart, then I can say it's an acute little angle. It's the smallest angle there is as far as our classification purposes. When your angle equals exactly 90 degrees, this is called a right angle. So when you see a right angle pictured, they're either going to tell you that this is 90 degrees. A lot of times they're just going to put a little square there, and that indicates that it's a right angle. One key thing to remember is if you just see an angle drawn like this, you cannot assume that that's 90 degrees. It could be 89. It could be 89.5. So just know that it needs to either have 90 degrees labeled in here or the little box. We're going to also learn later on that perpendicular lines form right angles, but that'll come later on. And then the third classification is an obtuse angle, and this is going to be an angle between 90 and 180 degrees. So that's a really large angle. And then the last one is a straight angle, and that one equals exactly 180 degrees. A straight angle also looks like a straight line. This is the only thing that you can assume is a straight angle when it's a straight line. And it's 180 degrees in total for this angle. So now we're going to try some examples of giving names to angle measures as well as learning how to read it on a protractor. So on the next slide, let's go ahead and I'm going to highlight each one. So the first one, I'm going to go ahead and highlight GHK. I'll go ahead and do that one in red. So I'm going to find point G, then H, and then K. So as you can see, this angle is pointing over here to the left. So I want to start my count up starting at 0. So I'm going to use the outside numbers. And then I'm going to make this go up here. And then wherever this line hits on these outside numbers, that would be the measurement of that angle. And this is hitting at 125 degrees, making this an obtuse angle. Then for the next one, I'll go ahead and go over that one in blue. So I'm going to start at J, and then I'm going to go to H, and then to L. So it points to the right. So this time I'm going to use the inside numbers, because again, I want to start at 0 as my count up for measurement. And then it's pointing to the 90. Now here, once you look at that, the 90 is both for the inside and the outside. So this is a 90-degree angle, making it a right angle. And then the last one is LHK. So L is here, H is here, and K is here. Now notice this time, it's not pointing at the 0 in either direction. So what I need to do here is I need to subtract to figure out how big this angle here. And it doesn't matter if I subtract the 2 inside numbers or the 2 outside. So if I do the 2 inside numbers, if I zoom in here, this one looks like it's hitting it at 55 and then 90. So I could do 90 minus 55 and get 35. Or if I did the 2 outsides, 90, and again, that was the 125, subtract those, and I still get 35 degrees either way. So this is a 35-degree angle, making this angle an acute angle. Now, one thing that I always use as like a reference tool, since you guys are taking your tests on paper, if you're ever trying to classify an angle and maybe they don't give you measurements, always use the corner of your paper, because this forms a 90-degree angle. So like if I tried to fit this in here, and notice how it fits perfectly for the blue one, that could be a clue that that's going to be a 90-degree angle. But again, you can't assume it. You would have to have other characteristics here. But as far as obtuse or acute, if you tried to put this paper say over here in this obtuse angle, you see how the red one is a lot bigger than the corner, so that's how it would be a clue that it would be obtuse. A lot of times it's pretty obvious. If it's, you know, smaller than the 90 degrees, it's acute. If it's bigger, it's obtuse. All right. Let's see what's next. Congruent angles. So just like we had congruent segments, we can also have congruent angles. And these are just going to be angles with equal measures. Now notice this little M in front of the angle symbol. All that little M in front just means the measure of. Because notice the first one, the measure of angle A equals the measure of angle D. When they give me something like this, then chances are they're going to tell me what that measure is. So like in this picture, they might have said, well, this one's 20. So then that would tell me that this one's 20. When I see the congruency symbol, I don't care what the measure is. All I care is that they're the same size. And in a lot of cases of that, they would just have the congruency symbol. So just understand that you can, whenever you see two angles that are joined by that congruency symbol, know that those are going to be two angles that have equal measure. Next, we're going to see a postulate. And this is postulate number 4. Again, this number is not important to us. This is actually just the 4th postulate we've learned. And this one is called the angle addition postulate. Just like we had the segment addition postulate, now we can apply the angle addition. And again, I could abbreviate this with an angle, P. So AAP, that's my abbreviation for this one. And this one states that if point B is in the interior of AOC, then I know that the measure of AOB plus the measure of BOC is going to equal the measure of the whole thing, which is AOC. So for example, AOB would be this little one here. And then BOC is this one over here. And when I add those two together, it's going to give me the measure of the whole thing. So if I told you AOB was 20 degrees and BOC was 30 degrees, then to find the measure of the entire big angle, AOC, I just add those two. And this is my angle addition postulate. You can do the same thing if it's a straight angle. Remember, a straight angle, once you add those two individual angles, they will always add up to be 180. Tomorrow we're going to learn about special angle pairs. In addition to this being sitting on a straight line and sharing that 180, you can also say that these are supplementary angles, but this is all going to come tomorrow. So if I use my angle addition postulate, and let's say instead of them, if I gave you both, let's say I only gave you one. Let's say I told you that JKM was 110, and I ask you to find the measurement of MKL. So here's how we could set up an equation to figure out that missing angle. So 110 plus X equals 180. Subtract the 110, and X equals 70. So this is another way that you can use your angle addition postulate when you know the whole amount and you know one piece. To find the other piece, you would subtract. So this is your angle addition postulate. Just like we had segment bisectors, now we have angle bisectors. So the bisector, okay, so just like before when we saw segment bisectors, now we have angle bisectors. An angle bisector of it, or a bisector of an angle, is going to be a ray. And that ray is going to divide the larger angle into two congruent adjacent angles. So if you're aware of the vocabulary word adjacent, adjacent means next to. So these are going to be two angles that are next to each other, and they're going to end up being congruent because the original angle that was here was ABC, And then BD is the one that split. This ray split the original ABC angle. So BD is the angle bisector of angle ABC. And these are all different ways that you could say this. So you could either be told that BD bisects ABC. You could also have been shown that angle ABD, the red one, is congruent to the blue one. And then that would also identify BD as the bisector. So again, you can't assume that something's been bisected just by looking at it. You're either going to need to be given that these two angles have the same measure, or they might even have congruency marks indicating that they're congruent. Then you could tell that ABC was bisected. All right, the next slide is showing congruency marks. So just like we saw before at the beginning of the chapter, congruent segments are going to have these little like dash marks or tick marks. Congruent angles are going to have little arcs showing that the two angles are congruent. And then when it's a right angle, it's going to have a little square or a little box there. Now, if you have more than one pair of congruent angles, so for example, let's say I show two intersecting lines, and let's say I number this as angle 1, 2, 3, and 4, I could show that angle 1 is congruent to angle 3 by putting a single arc, and then I could also show that angle 2 is congruent to 4 by putting double arcs. So you're looking for matches on the pictures of the arcs that are there to show what is congruent to what. So those are congruency marks. Now we're going to practice everything that we've learned and do some examples here. So the next slide, we're going to practice giving names to angles based on what's there. So we're going to modify it. Pretty good on this slide. All right, so it wants us to give another name for each angle. Now, whenever you're asked to do something like this on a test, for example, for number 1, there's actually 3 different ways that I can name this, in addition to the one that's there. If they only ask you for one, just give me one answer. If on a test they ask for 1 and you give me 2 and one of them is wrong, you're going to lose the point. You're going to get the whole thing wrong. So only give me one answer if that's what they're asking for. Now, if they asked me to give all the names, then you would have to list everything. But read the questions carefully, because you don't want to give me more than I need, because if you give me more than I need and one of them's wrong, the whole question's now wrong. So you can't try to cover all your bases and put 2 answers and think, oh, one's right, one's wrong. Maybe she'll give me full credit, and it's not going to happen. You lose everything. So just make sure you read carefully. All right, so let's go ahead and give another name for DEB. So let me go ahead and trace around this. So D, and again, the order matters. So we're going to go from the D to the E to the B. So I'm going to trace around it so I can see where the angle is located. So the easiest other name I could come up with is just reverse the letters. And I could say that this is BED. Now, I can't name it just angle E because there's 2 that have vertex E. But I could also, because it's got a little number here, I could call this angle 4. And notice, because these are rays that are forming the sides of my angle, I could also have gone all the way to C, and another name for this could have been CEB. And you could reverse that one as well. The next one, and let's trace around, I'll trace around this one in blue, CBE. So C starts here, B is here, and then the E. So let's go ahead and fill in the rays to show the angle. So you can already see that this is angle 8, and I can also reverse the letters on this one. So I could also say this is angle EBC, or I could have also said it's angle 8. No other names for this one. For number 3, this one is BEA. So here's B, here's E, and here's A. For those of you who don't know, that's the lightning warning. If you ever hear that go off and you're outside, know that there's lightning in the area. That's the lightning alarm. Okay. So this one, BEA, again, I could reverse the order of the letters. So I could call it AEB. I could also call it angle 3. And that's it on that one. Number 4, DAB. Let me go ahead and trace around that one. So start at D, and then I go to A, and then to B. So in the order. So I could reverse the letters again, BAD. I could also call that angle 1. And this is another one where, remember, the ray keeps going. So I could have also started at C and said angle CAD, or reverse that one as well. Number 5, which is angle 7. So here is angle 7. So let me make the rays that are going to form that. So that's going to go from here to here. So again, I can pick letters, and I put my arrow on top of that. Let's see what that letter was. Okay, so for that one, I could start at DCB, or I could reverse it. I could also have extended it all the way down, and I could say EC, and even take it all the way to the A. Just remember, what's important here is that C is in the middle. So that one has a bunch. And again, you could reverse any of these. Angle 9. Let's see. All right, so angle 9 is right here. Oops, I didn't switch the color. Here's 9, and it's made up of these two rays. So again, order, the B needs to be in the middle. So E, B, A, and I could also reverse it. A, B, E. That's all on that one. Now, 7, 8, and 9 are using my angle addition postulate. So maybe, let me see if I can erase some of these colors so it's not so messy here. Okay, so the first one, angle 1 plus angle 2. Well, here's 1, here's 2. So together, they're going to form this angle. So I'm going to call this angle CAE, or I could have even just started at BAE. And again, any combination of those would be okay. And then the next one, adding 3 and 4 together. 3 and 4 are up here. So once I put those two together, that's going to give me angle AED, or it could give me AEC, any of those. And you can reverse it. Yes. Yes. Okay, and then 5 and 6. So 5 and 6 are over here, straight line, straight angle. So together, it's going to form EDC. Or I could reverse it and say angle CDE. Okay, this is a straight angle, and then tomorrow we're going to learn that when you have a straight angle and it's divided into 2 angles, they're called supplementary angles. All right, one more example. We're using our angle addition postulate here. We're given that angle LKN. So here's LKN. Here's the angle. And this whole thing measures 145 degrees. It wants me to find each one of these other angles individually. So it wants me to find the measure of LKM, which is right here, and MKN. So here's where I'm going to use my angle addition postulate. So I'm going to be adding the two angles together. So I'm going to take LKM plus MKN, and that's going to equal LKN. So I know LKN is 145. I know that this one, and what did I do here? This should be an L, sorry. This is LKM. This first one is going to be 2x plus 10. And then this one is the blue one, and this is an angle symbol here, MKN. And this is equal to 4x minus 3. And now I have an algebraic equation to solve. So now I'm going to combine my like terms. This gives me 2x plus 4x is 6x. And then 10 plus negative 3 is 7. And now I have this to solve. Subtract 7. 6x equals 138. Divide by 6. And x equals 138. Divide by 6. 23. Now, it didn't ask me to give the value of x. It wanted me to find the measure of the two angles. So now what I need to do is take this 23, plug it into this expression, and plug it into this expression. And then that's how I'll get the measure of those two individual angles. So the measure of LKM is the 2x plus 10, and the measure of MKN, this is the 4x minus 3. So let me plug in 23 into both. Now remember, these are not congruent angles, so they're going to give me different numbers. So 4 times 23 minus 3, 92 minus 3, and I get 89. One way I can check to see if I've done this correctly is remember both of these added together need to equal 145. So if I do 56 plus 89 to double check it, I do get 145. So these two answers that I just got are correct. Now, if it would have said that KM was the angle bisector, then instead of setting them equal to 145, I would have set the two expressions equal to each other. So this is where you're going to have to pay attention to what's given to you. Everybody good? All right, so now we still have a few minutes. I'm going to start going over some of the homework problems with you, and I'm going to show you what they should have been in simplest radical form.